So before we continue on, let's take a second and look where we are at with the substitution reactions. So let's compare these two and look a little bit about their similarities and differences. So remember with the SN2 reaction, SN2 reactions really like to not have steric crowding. And so this comes from the transition state during the mechanism. So remember in the transition state, we had those three bonds in alignment in the center. This created a lot of steric crowding, and so with larger groups around the center carbon, that made it more difficult. So SN2 reactions, like our electrophilic carbon, so remember the electrophilic carbon is the one that's attached to the halogen, we like it to have as little carbon groups attached to it as possible. So SN2 reactions tend to favor primary and methyl halogens. And this is going to be important. This is going to be one of the main ways that we are going to be able to tell the difference between SN2 and SN1 reactions. SN2 reactions favor primary and methyl halogens. So halogens where the electrophilic carbon doesn't have a lot of steric crowding. By that I mean there's not a lot of extra carbon groups attached to it. SN2 reactions are also favored by good nucleophiles, and this is because nucleophiles are involved in the rate determining step. So good nucleophiles, by that I mean lone pair electrons and negative charges, they tend to favor SN2 reactions. The last thing to remember is that every reaction that we talk about in here, so we're going to be talking about 4 of them, has its little idiosyncrasy that you got to remember. In SN2 reactions, remember that the stereochemistry is inverted, and this comes from the mechanism itself where we have backside attack that the stereochemistry is inverted. So whenever you get to a point you say this is an SN2 reaction, you have to say, do I need to worry about the inversion of stereochemistry? So SN1 is, remember, kind of a mirror image, and the difference is mainly in the mechanism. During an SN1 mechanism, we form a carbocation, so it's a violated octet. So carbocations like having alkyl groups attached to it. So remember, the alkyl groups stabilize the carbocation through hyperconjugation. So the more alkyl groups that are attached to our electrophilic carbon, that's the one attached to the halogen. Remember, in the first step, that halogen is going to pop off and form a carbocation. The more alkyl groups that are attached to it, the more stable the carbocation is going to be in our mechanism. So SN1 reactions really like to happen when we have tertiary halogens. So the electrophilic carbon, the carbon that's attached to the halogen, actually has 3 alkyl groups attached to it. More alkyl groups mean more stabilization from hyperconjugation. So SN1 reactions tend to favor tertiary halogens. So you can already see the major difference. Primary halogens, SN2. Tertiary halogens, SN1. Also, SN1 reactions tend to be favored by poor nucleophiles. So poor nucleophiles are ones that have lone pair electrons and no negative charge. And the idea here is poor nucleophiles don't have the strength to go in and cause the reaction to occur. What they need to do is hang around and wait for the halogen to pop off. And that's what happens in the first mechanistic step. The halogen pops off, or the leaving group pops off to form the carbocation. Then once we do that, once we have a carbocation, we have a carbon with a formal positive charge, then the poor nucleophile can come in and attack. The other thing that you need to remember is that in SN1 reactions, the stereochemistry is lost. So by that I mean, it doesn't matter if I start with an electrophilic carbon that has an R or an S stereocenter, we end up making a racemic mixture. So if I start with R, what I'm going to end up with is R and S. So that's its idiosyncrasy for the SN1 reaction. Whenever you say, oh, I'm doing an SN1 reaction, you have to take a second and say, do I need to apply this? Is there some kind of stereochemistry or a ring or something like that? And we'll see some more examples of this later on.